Hello and welcome to the webinar. My name is Josh McDaniel and I work with the Wildland Fire Lessons Learned Center. I think we have an interesting and very practical and useful presentation today. Chuck McHugh is going to describe some of the changes and new features available in FlamMap5. But before I introduce Chuck, I want to make a few announcements. First off, this webinar is part of a webinar series sponsored by 3 organizations, and that's the Joint Science Program, International Association of Wildland Fire, and the Lessons Learned Center. And like always, I put up the links to their websites here and encourage you to check out some of the resources that are available there. Okay. Also, I want to announce we have upcoming webinars. There are a few that have not been finalized in September, but we're working on getting dates and registration finalized for those. But the one that is locked down is J.C. Drury is going to be giving a presentation on the IFT DSS system on October 18th. And the registration link is available there, and that's at the Advances in Fire Practice webpage. And check the Advances in Fire Practice webpage as well for updates on webinars coming up in September if you're not on the email list. You can get to the Advances in Fire Practice page by using this link, or you can Google Advances in Fire Practice instead of typing this in, or navigate there through the menu on the Lessons Learned Center website. And there's a place right at the top that has all the information on the webinars. Okay, so real quick, I want to do a couple polls to find out a little bit about our audience. Okay, so first question is, who is your employer? Alright, pretty much everybody's voted there. Or not voted, I guess responded. Alright, so close that and share. Okay, so we got 74% federal land management agencies, 13% state and private, 10% university, college research institutions, and then 1% NGOs or private industry. Okay, so let's try the next question, and that is, what best describes your connection to wildland fire? Okay, put that up. Share, is that showing? Okay, so 74% fire and land management, 17% research, 4% outreach and education, 13% administration and planning. All right, so just a couple quick notes about the webinars. We encourage questions, and please type your questions in early and often. So if there's anything in the presentation you have a question about, type it into either the questions or the chat box, depending on what platform you're on. And we'll have a question and answer period at the end of the presentation, and we'll try to make it through all the questions if possible. Also, the webinar is being recorded, and that the link to the recording will be available on the Advances in Fire Practice webpage. We're actually going to try we have a YouTube channel. We're going to see if we can get it uploaded to that as well. So we'll start archiving the webinars on YouTube on the Lessons Learned Center's channel, and I'll provide some information for that at the end of the webinar. All right, so that should take care of the housekeeping. I'll give an introduction of Chuck McHugh. Chuck McHugh works in the Fire, Fuel, and Smoke Science program at the Rocky Mountain Research Station at the Fire Science Lab in Missoula. Chuck started out as a seasonal employee with the Forest Service from 1981 to 1989 on the Mount Hood National Forest. During that time, he worked in timber, silviculture, fire, and wildlife management, performing a wide variety of duties. From 89 to 97, Chuck was on the Coconino National Forest as a pre-sale forester and a district GIS coordinator. During the period of 97 to 2002, Chuck served as the FARSITE coordinator for the forest in Arizona, and his duties included the development of FARSITE data layers as well as model and data evaluation. His research interests are wide-ranging and included work on post-fire tree mortality, fuel treatment effects, and climate change. He currently serves on the S495 steering committee and faculty for this course, and has a long and is a qualified long-term analyst. All right, and so with that, I will hand it over to Chuck.
Thanks, Josh.
Not coming up the pole, getting in the way there. There we go.
All right, well, hopefully everybody's here to see an introduction to FlamMap5. We're going to talk, it's been a long time coming from FlamMap3 to here, so with that we'll get going.
Chuck, your PowerPoint's not up yet.
Do I have to, it didn't ask me to take the screen or any, oh.
Here, I'll take it back real quick and then give it to you. All right. There you go. That should do it.
Okay. Sorry about that. All right. Is that better?
No, it hasn't come up yet.
It says it's on air showing screen.
On my end, I'm not. I'm just getting the sort of landing page. Let me try that one more time. Okay. Sorry, folks. We'll straighten out in a second. Okay, so I brought it back to my screen. Now I'm gonna hand it to you. There we go. Okay.
All right, sorry about that. So with FlamMap5, this is just going to be an introduction. I'm assuming that people on the webinar have some type of familiarity with using FlamMap3. This really isn't a formal training session. I'm only going to really try to introduce what's new and navigate through some of the screens. And I'll start out with this little PowerPoint first before we go right into the program. So what's new in FlamMap? Well, it addresses a lot of the, hopefully all the known bugs that existed in FlamMap3. Probably one of the big things that's going to make life simpler for evaluating large landscapes is we have it available in both a 32-bit operating system and a 64-bit operating system version of the program. So if you have a computer that's running a 64-bit operating system like Windows 7, you can take full advantage of the memory in your computer now rather than the limitations imposed by the 32-bit operating system types. And the installation notes have a pretty good discussion on how to tell what your operating system is and determine, because it does make a difference on which version of the installation that you install it in. You're always you'll never want to install the 64-bit version on a 32-bit operating system. It just won't work very well. Another big thing is FlamMap can incorporate projection files if you provide it with the landscape when you build it. There are some limitations. We'll talk about that real quickly. WindNinja is embedded in the program now, so you can use WindNinja to develop gridded wind fields in every analysis type in the program. But you can also bring gridded wind fields from outside of FlamMap. You're not restricted to that. You can bring, if you use WindNinja 2, the standalone version of the program, you can develop your wind streams in there and load them in. Or if you're using WindWizard, you can use that program and bring those in as well. From a fire behavior thing, probably the big thing is spotting's included now. A major limitation of FlamMap3 was whenever you're doing minimum travel time calculations to look at fire spread, spotting wasn't accounted for in the program. So we've done that. Barrier files can now be used during MTT analysis, and I'll show you some examples of that. And then from a risk analysis standpoint now, the data that you need to conduct a risk analysis in terms of fire behavior characteristics, fire burn probabilities, and probabilities of fire characteristics are all now available in FlamMap5. So you can use the outputs from FlamMap5 to conduct a risk assessment and the effects on values at risk that you might be interested in. And while this isn't a risk assessment webinar, we'll talk a little bit about these outputs out of FlamMap just so you can see what they are and how they could be used. So from a documentation standpoint, we are a little bit behind on the help file. The FlamMap3 help file is embedded in FlamMap5, and a lot of it is still applicable. The vast majority of it is still applicable. What's not going to be in there is some of the new information and what you need to know, but we've written up a release notes which we hope fills the interim void of that. There's also some installation notes that are critical because of the difference in the operating systems and the different installation files. There's some pretty important things you need to be aware of there. And we are starting to work on updating the help file so there won't be two separate files. Everything will be embedded in the newer help file version. So where do you get it? So if you go to the same place you can download most of the national applications that are approved, like Behave and Fire Family Plus. If you go to firemodels.org, and then if you come over to National Systems, down to FlamMap, and you can see that there's information. We've tried to update all this information with just a general description of the program, an overview, some of the screenshots that are there, publications that are relevant to it. If we go to software and the downloads, probably the biggest thing, here's where you can download the program from. You'll notice that it was updated even as of this morning. We just put a new installation file up. And it talks about the two different versions here are pretty well defined. Then of course I highly recommend downloading the installation notes and the release notes for the program. And with that, that's where you can retrieve the program and download it from. So just a little refresher, all the programs, FS Pro, FARSITE, FlamMap, all use this grid sandwich of data. Nothing has changed there, though we've added one thing to it. It all consists of the elevation, slope, aspect, fuel models, canopy characteristics, just like you would get from the land fire data. But we've added the use of projection files. So if you have a projection file with your landscape file and you include it in the same directory as the landscape file, now anytime you export any of the outputs out, that projection file will come with it. It's in a standard Esri format. The key is that it has to have the same name as the landscape you're going to use. And right here, you can see just an example here is a pretreat.lcp file, and the projection file needs to be pretreat.prj. It should be in the same directory as your landscape. And then, like I said, any geospatial outputs that come out of FlamMap that you save will have a projection file with it now. But the big caveat to this is with the projection file is you can't use that information to project on the fly or to reproject your data. So within FlamMap, it's still important that all your geospatial data using in your landscape or in any auxiliary data themes that you want to incorporate into your project, such as boundaries, roads, streams, that kind of stuff, still all have to be are still required to be in the same map datum and coordinate system as the data that was used to create your landscape file. So again, unlike ArtMap, it doesn't project on the fly. So that's the big restriction there. The other thing, though, that including a projection file does is now we can create GeoTiff files of your GeoTiff versions of your landscape that have the projection information embedded in it. We're just starting to go this way and investigate changing the landscape file formation and what it is. Basically, in FlamMap, what it will do is it will create a multi-band 10 multi-banded 10-band GeoTiff, and it'll always create 10 bands regardless of whether you have the data for all 10 bands or not, but it will still create it. This GeoTiff file that you get, you can use in WindNinja. So if you're using the standalone version of WindNinja on your computer, you can load either a landscape file or a GeoTiff file into WindNinja, and it will use that information to bring you into where you want to have your domain, where you want to calculate your gridded wind fields for. It will use the canopy information from that to determine what the surface roughness is, etc. The GeoTiff files, too, are also compatible in ArcMap, version 10 or greater. You can't see them in 9.3. But in ArcMap 10 or greater, you can load a GeoTiff file that's a landscape file, and it will let you change the band combinations. It's a 3-banded GeoTiff, or you can load each of the individual GeoTiff bands as a separate layer. So if you go into ArcMap and you get deep enough into it, you can load each individual layer as a single TIFF file. The big caveat is you can't use these in GeoTiff files for landscape files in FARSITE. It's a way that we're going of looking and investigating it because we realize that the ASCII file and the formations that we've used in the past make for some rather erroneous, very large files that are hard to move around and handle. And the GeoTiff is just a different way of bundling it. So down the future, we'll probably go strictly to that. Here's just an example of what the GeoTiff files will be. The orders that they're in, you'll see that it creates them in the same order as the input order would be as you're generating a landscape file. So elevation, slope, aspect, fuel model, canopy cover, stand height, and then the floating and coarse-woody fuel themes. And it will always create 10 bands in there. But the release notes go into this a little bit more. So like I said, one of the big things is that we've included spotting and barriers, and that spotting is now incorporated. So to do spottings, here's some things that you need to know. You have to have canopy characteristics, so you need a crown base height, crown bulk density, and the stand height. You as a user can set what the foliar moisture content is. The spotting is always assumed to be from a grand fir that's 8 inches or greater in size. You set the spotting probability on the MTT tab, and I'll show you that. It's a fractional format. You can use a wind speed that is either constant for the entire burn period, a static wind speed, but you can use gridded winds, either WindNinja or WindWizard. And also you could have the wind be either from a downhill or an uphill direction too. And the weather is static, though you can condition the fuel moistures to bring them to the point that you want them to be. So this is just one example of what a spotting run would look like on a FlamMap using the minimum travel time pathways. So what we're looking at here is the yellow, red to yellow is the arrival time, and then all these little black squiggly lines here are all the pathways that FlamMap used to determine how the fire was moving across this particular landscape. But you can see the spotting shows up pretty well. So here's one example of a spot that landed here, and if we trace it backwards, we can see the cell that it came from. So here, the ember came from here, landed somewhere in here, and started a new fire. If we trace this spot that launched from here, it went clear out to here and landed here and started a new fire. So this is one way that you can see how spotting is manifested in the use in the minimum travel time analysis now. So barriers, I talked about barriers. We can have barriers now for use in FlamMap5. They can be an existing shapefile that you've created outside, as long as that shapefile is in the same map datum and projection as the landscape file you're going to associate it with. You can create them interactively in FlamMap and save as a shapefile, and then add to the run as a barrier. Barriers can be points, lines, or polygons. So this is an example of spotting with an unfilled barrier. This is the same, similar data. The underlying theme here is the arrival time with red to green, red to yellow. Here was the line ignition. This is the barrier that I incorporated and I didn't fill it. And you can see that the fire spreads right up to the edge of this because this while this is provided as a polygon, when it creates it to a vector, it makes it equal to one cell of the landscape that you're using. So in this case, it's probably a 30-meter cell right through here. You can see that if we trace the rays back, we can see that this fire that started within here came all the way back from probably right about here and spotted into it, and then the fire spotted out of the barrier as well. So you can see how spotting is used with can be affected, or how the barrier works with spotting. If I fill the barrier and say that everything basically within that polygon is unburnable, we see the same thing. It burns up right up to the edge of the polygon. And if we trace this ray all the way back into here, we can see that that spot, the amber that was lofted that started this fire, came from way back here over it and came up to here and started a new fire, and then somewhere in here it spotted again and started this pathway. And you can see how the fire spreads up against it and then flanks around the barrier. So that's a couple examples of spotting, and then spotting in use with different types of barriers. So the big thing here is burn probability in FlamMap5. Conducting risk assessments in fire management requires several things. One, that you can really have some really definable and measurable objectives, and that to evaluate those appropriately and have some kind of quantifiable options that can account for changes in the fire likelihood, burn probabilities, fire behavior characteristics such as flame lengths and the probability of those occurring, and then the intersection of these burn probabilities and fire behavior characteristics with values at risk, and then what effects those have on the changes to values at risk. And wildfire can either have positive effects or negative effects depending on the type of values you're interested in. So with FlamMap5 now, we have a way of getting at least from the fire behavior, the fire and the likelihood of those and the probabilities of those occurring, we now have a way to get that data out of a program like FlamMap5. And so it includes all these additional outputs. You can, for risk analysis, your ignitions that you use in the burn probability analysis in FlamMap, previous versions, they could only be random. Well, now you have the option of still using random ignitions as determined within FlamMap, or you could provide a ignition file all on your own. What that does is then you can use that same ignition file over and over again and use the same ignitions and then examine the changes of differences in fuels treatments, let's say, or different environmental conditions and how they impact your outputs or how they might be affected by changes you want to make to the landscape in terms of fuels. So that's a pretty big bonus. You get all the individual MTT fire perimeters. So if I do simulate 1,000 separate fires, I get all their I can get shapefile representation of their perimeters that it used. And then we get these flame length probabilities, and they come in both metric and English, and you can get them in English units or metric units, and they have different groupings. The English has 6 classes, and the metric has 20 different classes, and they're usually in increments of 2 feet or a half a meter between the groupings. All this information is exportable out as a text file, including information on individual fire size and their locations. And all these outputs can be brought into ArcFuels to conduct risk assessments for an area. I know Nicole is working on taking these outputs and incorporating them right into ArcFuels to help with those risk assessments. So just an example here of what that might look like if we say here's one example of a burn probability run. So we're looking at the burn probabilities overlaid with the MTT perimeters themselves. And this was just a very few number of fires across this given landscape. But you can see here there was a single fire event, and here is its shape as a perimeter and its burn probabilities associated within that perimeter. And then if I have with this fire size list text file here, I can make a point shape file of those, and those points should line up within these perimeters. Where you see here, like this instance here, you have two fires that burned in the same spot, just with relatively different starting locations. So this is an example of what that output would look like. I talked about the outputs of the fire length probabilities being, flame length probabilities being in different classes. In this case, this is the English version here. So if I do 100 fires, for every fire I get its starting X and Y position. I get this overall burn probability of it being burned, and then I have the each individual probability of a different fire intensity level, which are based on flame lengths. So here's class 1, 2, 3, 4, 5, and 6 out here. Sorry about that. X position, Y position, the overall burn probability, and then these set of, great. Don't you love that you can't control. So here we go. Here was the overall burn probability and those fire intensity level probabilities. Here's an example of the fire size list. Here's its fire number. So the fire numbering is a little weird in that it starts at 0 and works sequentially up. So if you have 100 fires, the first fire would be 0 and the last one would be 99, but there's 100 fires. Here's the X position, the Y position, and then its fire size in acres is right here. Okay, and then with that, if there's not any questions before that, we'll move right into the program.
Yeah, there was one question from Steve Garza. Let's see, it says, can you use FMP run files from FlamMap5 and FlamMap5?
No, unfortunately, there's probably going to be some problems with opening up project files that were done in FlamMap3 and trying to open those in FlamMap5. One of the problems we've had is as they've shut down on security, like you see there, I couldn't change the hibernation mode of my computer even. They've locked down the install location that we used to use for FlamMap3, which was under the program files area. And we can't install it there anymore because FlamMap5 requires the use of having the ability to write temporary files to wherever it's installed. So we've had to change the location to a different area on people's computers, which is the C workspace area, which on most federal computers is going to be an open area that has read-write access. So probably any projects that you have because of that may not open up completely or open at all. But Steve, if you get to that where you need help with that, let me know. And there's at least a way that if you save and archive your project, you can at least bring all the files with it, but the settings probably won't be there and you'll have to reconstruct those runs. So sorry about that.
Okay.
Okay. So when I open up FlamMap5, it's going to look a lot like this right here. And you can tell which version of FlamMap you're running just by clicking on the help about FlamMap. You can see here that I'm running the newest version of FlamMap in a 32-bit operating system, which I'm running on my Forest Service laptop here for this example. There's a couple of new things on the toolbar that you'll see. You'll see this green text and a green PDF. And I'll show you an example of that, but what that does is it does some analysis on the landscape file that you've loaded. If you've used this function, it's the same function that if you're familiar to using the WFDIS system in the FS Pro, when you go to build a landscape, you can click on a button that says critique landscape file. Well, this is basically the same thing. So I'm just going to open up a new landscape file. Now, not much has really changed. The look, the feel, and everything to FlamMap5 is going to be real similar to FlamMap3. So I've loaded my landscape. Same thing before. If I click on this by auxiliary themes, I can add additional information. I can change the view of the data theme I'm looking at, whether it's slope, aspect, fuel model, which is the defaulted view. If I click up here, I can get a shaded relief view of that. If I want to look at a critique of this landscape, I just click on that button and tell it where I want to save it. And it saved it to that location, and now hopefully it'll show up. And so what this does is help you quickly evaluate the landscape you're dealing with by giving you data ranges, the themes that are present in your landscape, the value ranges of those themes, the distribution by individual themes in terms of bar charts and graphs. If you, as you scroll through it, you'll see a JPEG of each of the individual data themes and a legend associated with that. If I scroll through here, after I get past all those, then it'll start to show me by fuel model the distribution of the other characteristics. So it'll show me the examples of the elevation that fuel model is associated with, its meters, and the percentage of pixels across that landscape. And I can see that for every value associated with that fuel model across the landscape. So it's a quick way to evaluate and look at your landscape for any issues that might pop up and are easily identifiable. Okay, and I said that I could turn the landscape into a GeoTiff. There's several ways to do that, but if I just do File, convert LCP to GeoTiff, select the source LCP that I want to use, and if there's a proper projection file that it recognizes, this area will be grayed out. Tell it what I want to call it. Say OK. And now it's successfully created that GeoTiff. Like I said, that GeoTiff can be used in WindNinja or brought back in as a landscape here. If I start up a new instance, new analysis project here, click on landscape, change this to the GeoTiffs, and I can get the same landscape there. So we'll talk about the Run tab now. The look and feel of this is not that much different. Things are going to look really similar to you. One thing that's changed is that you used to be able to start a run or initiate a run from here at this tab. We've changed it now so that you need to start the run at the tab that you're interested in, whether it be minimum travel time, the treatment optimization modeling, or the fire behavior outputs. So that's one different on this tab here that you'll see. We've changed some things with the fuel moisture files. I can either add a fuel moisture file that I've already created, which is still the same old standard fuel moisture file. I can do it as a text editor and create a fuel moisture here by hand if I want. Or we've added this function, which is this plus button here. And we can create, by doing this, we can create a set of defaulted fuel moistures for your, or a set of fuel moistures for your landscape file initially. We have some defaulted values here that come in for the 110s, 100s, herbaceous and live woody, but you can change any of those at this point. In fact, they should be changed because rarely would they probably fit your individual circumstance or what you're trying to do at this time. In this case, I'm just going to say OK. Now it creates this file and it interrogates the landscape, and you'll notice that it creates, for every fuel model on the landscape, it knows what it was and it adds those fuel moistures across there. One thing that it does that's different too is it creates this fuel model 0, which is kind of a defaulted fuel moisture file. And what it will do is it will apply those values to any fuel model on the landscape if it's not accounted for in a fuel moisture file. Conversely, if I don't care about having variable fuel moistures by the 110s, 100s, live herbaceous, and live woodies, I can get by with just having a fuel moisture file that only has that information in it. If I just put a fuel model 0 and the associated fuel moistures in this format, I can use that as the fuel moisture file. So whether that's appropriate for the circumstance you're in or not, that's up to the user to determine. So I'm going to have my fuel moisture file. So when we get to the winds now, we have some options here. If I say a wind direction, I need to put in the speed and the direction I want that to come from, and that'll be a constant speed and direction for the entire time. If I say I want it to be wind blowing uphill or downhill, then I don't need a azimuth because it's going to use the topographic information to determine whether the wind's blowing uphill or downhill. If I generate wind vectors from WindNinja, you can see that it'll populate this box, and now whatever I put in here is what's going to be used to initialize the wind flow in a WindNinja run. So we've incorporated WindNinja directly into FlamMap5. So what I have to do that is give it a speed and a direction, and then there's one other thing you need to do. You need to click on this WindNinja options. So there's two critical things here. One is this resolution. On 32-bit systems, WindNinja, if you have a large landscape and you have a really fine resolution here, you can run out of memory on your computer, which will cause it not to calculate the wind information. So what we've done is it'll come back and spit out to you what an ideal resolution is. And what I mean by ideal is that it means that it's calculated how many numbers of WindNinja wind cells that would be that likely won't make you run out of memory and crash the program. You can change this, but in this case it came back at 30, which is the resolution of the landscape I'm using. If you want to use diurnal settings, if you want to have some diurnal flow into your wind program, then you need to provide it some information. And unfortunately right now, we don't have it to where it would interrogate your landscape and the projection information and self-populate this for you. So this information here is up to the user to use, to tell it what time zone you're in, the longitude, the cloud cover, and the air temperature that you want it to use. And for this, for help with this, I really reference you back to the WindNinja program and their help file and their help information on how those settings come into play and what to use. And we've tried to incorporate it into a fairly good discussion into the release notes on it. In this case, I'm not going to do any diurnal simulations. So this option here in WindVector Files is I can bring in information, if I have it, from outside, developed outside of FlamMap, and that could be either from the standalone version of WindNinja or the WindWizard program. And it's just like it was in the past. I just click on the WindVector Files, come to this button, and then select the file I want. And so then I can use gridded information developed from outside the program if I want. And even though I have this selected here, if I change my mind and click back to here, it's going to use this information to develop the wind stream. So if I say apply, now we'll just go to fire behavior outputs. You can do flame lengths can be, I'll just pick some flame length and crown fire activity. I'm going to pick Scott Reinhardt method, and I'll just say apply and then launch. So the first thing it's going to do is calculate all the WindNinja vectors for me. Then when it finishes that, it's going to do the fire behavior, and now it's done. So if I come over here, I can see here's the outputs, here's the wind vectors, the flame lengths, crown fire activity, a grid of the wind direction, and a grid of the wind speeds. So what you can see is that the wind speeds are redder. They're probably faster on the ridge tops than they are on in the bottoms and on the valley slopes. These purple arrows through here are the vectors themselves. If I come to properties, I can come to here and I can change some of the display issues with them. So now I've made them so that the green are the lower wind speeds and reds are the higher wind speeds. I can see up here that the data range goes from a low of 0 to a high of 36 miles an hour. And now there they are across the landscape. And if I wanted to bring in a 3D window and look at those, might be a little easier way to do it. I can tilt it, I can spin it around, I can zoom in and then see how those are flying across the landscape and how those arrows are moving there. So that's one way to look at that. I can zoom way in or way out. These wind vector data, if I save as, click save as, I can save them as a shapefile. And that shapefile is viewable in ArcMap as well as back up here. I can load them back in. And same thing with the flame length and crown fire activities. They're all still exportable as ASCII files just like they are in the past. You can change the legends on them, so people like the hauling categories, and that's the defaulted one, or you can change them in any direction that you want. So not much different with a basic run. One of the things that we've done that I think will be helpful is now you can copy a run, and as soon as I copy it, it opens up a new run, and it's associated with the landscape that I have it associated with, and all the settings that I had before are still in there. So here's all my fuel moisture file, the speed and azimuth, everything just like I had set up on that page. There's the fire behavior outputs that I wanted, and they're right there too. So now I'll just go to the minimum. This run I'm going to do a minimum travel time in, and I'm going to, so there's two ways you can load an ignition file in here. You can load a current shape or an MTT or from an existing shape file that I have. In this case, I'll use a existing shapefile, and it shows up there. These inputs are critical because they affect how things run in MTT. So I'm going to make this coarser so it runs a little faster. That's saying how much resolution of the calculations I'm going to do. I'm going to set the time that I want for each fire to run. In this case, one fire 360 minutes. I'll bump up the spotting and exaggerate it so that we can see something. So if I say 0.8, that's actually 80%. In this, we won't use any barriers this first time, and I'll select some outputs, and I'll say launch. One of the things that we've done through some programming tricks and stuff is that FlamMap will run much faster than it has in the past. I'm going to zoom in to where we were. And to make it a little easier, I'm going to put the arrival time grid up. So here in this arrival time, you can see that the ignition was somewhere right in here. You see all the flow paths. You can see the major flow paths, which are the yellow lines. And we see these wind vectors associated with that landscape based on the information I gave it. We can see that here's some spotting right up in here as well. So in the minimum travel time, it shows you the, you can look at the rate of spread associated with the vectors. You can look at the arrival time that we were just looking at. You can look at the ignition grid, that's what I used for my ignition. I had some flame length and rate of spread and crown fire activity associated with that. That's the basic fire behavior runs as well. So pretty much the same as you could see it, other than now you see spotting involved in the influence of spotting on changing how things are growing in the simulations. So if I want to copy this run, I'm going to say OK for now. And then if I wanted to use a different ignition, I come up and grab the drip torch, and I'm going to do it on here for now. But if I wanted to take a different ignition, I'm going to make a polygon ignition. It's just a series of left clicks, and then when I'm close, I just right click it and it will close the polygon for me. At this point, I can come up here to shape and save it to a file, which it will just let me save it that way. Or if once I draw that shape and I like it, I can just come to the new run, go to my minimum travel time, and if I say load current shape, it's going to take that shape and load it right into here, and now it'll act as an ignition. So if I say apply, and the difference we've taken now is that shapes are just generic shapes. If I want to have a barrier in here too, and I come back to minimum travel time, I can say barrier. Oh, okay. Sorry. So I save it there as a, call it what I want, come up to here, and then load it as a barrier. And I'm going to keep everything else the same, except for I've changed the ignition, and I have, we'll see what happens here. And there you go. So there we can see what I used as ignition file and the barrier file. And you can see how the ignition started down in here. Didn't burn through this because I had this as a field barrier, and now it took off running this way. So now if I want to do, we'll copy one more run, and we're gonna do a burn probability run this time. And I'm going to use just 100 random ignitions. I'm going to tell it that I want this information. So now what I'm looking at is these are the MTT perimeters of this entire landscape. Yeah. It's kind of hard to see, but these are individual perimeters, these red lines here, and that they're turned on and off by this MTT perimeters. If I save it, it'll save as a shapefile. I just tell it what I want it to be. Now that shapefile, I can, once it finishes creating, I can use that in ARC, bring that into any GIS project. I can load it in back up into here as a shapefile if I want to call it something else. I can change the colors of these if I want to. And everything there. So then you can see the wind vectors again are overlaid there in purple. If I come down to this fire size list, here's the text file that I was talking about. Here's the fire number. It's starting X and Y position, and then it's fire size. And this you can export at only as a text file. You'll have to bring that into some other program like ArcMap to create a shapefile representation of those points for that landscape. But it's easy enough to do. It's a fairly simple GIS operation to do that. And those points, once you did that, should line up in each one of these. The starting ignition should be associated with its MTT perimeter. Let's see. Oh, I'm almost out of time here. So, one other thing that we've done too that's I think I didn't like is I can have this entire landscape here, and I had no way to clip or change it. If I created a new analysis area, that new analysis area was only usable within the FlamMap project I had it. But now, if I just draw a box for an area of interest, you'll see I can either zoom to it or create a new analysis area. So I can create a new analysis area. And now if I come down here to my new analysis area, right-click it, I can create a landscape file. So in this landscape file, it can be either a GeoTiff file or a landscape file. So then once it creates it, so now I have a way to extract a smaller landscape area and save it and export it out as a landscape file, which was a function that we didn't have previously in other versions of FlamMap. Then there's been some other enhancements along the way, but if you download the release notes and the installation notes, we've tried to cover a lot of that information. So that's what I wanted to work through today. I know it's rather quickly and everything, but I hope that gets people opportunity to get started in using it. And on the web page, if you come across bugs, there's a way to under it there is a way to report bugs and get to the known bugs page. You know, you can, if you send the first tier of help for this is the National Fire Applications Help Desk, and they can deal probably with 80% of the issues that people have with the program, and then they have a second tier list of people that you can contact when they need additional help. So here's a list of the couple of bugs that have already been reported that we know of. So if you click on the Fire Applications Help Desk, it has the information you need to get a hold of them to work with bugs. Okay, and with that, I guess we can open it up to questions.
Okay. Thanks, Chuck. There are some questions already up here, and go ahead and get some more questions in if you have them. I'll start working my way down the list. First question is, will the landscape critique be in English units in the near future?
We don't have an option for that right now. It's going to be in what the base units it should be. We don't have a plan to make it to give you an option of that and convert it. It's going to be in these elevation in meters and the meters times 10. So for now, we don't have that option or that availability to change it.
Okay. The next one is from Julie Gilbertson Day. Is there a limit on the number of fires you can run?
No. I haven't found it yet.
Okay.
You should be able to run multiple thousands of fires. It'll just take longer, as it has to do it. As you increase the number of fires and increase the duration of each of those fires, that adds to the simulation time.
Okay. Is fire size, and Jim Wolf wants to know, is fire size in acres or hectares?
It's in acres.
Okay.
So that you get the fire size can be in two ways. One is in that fire size list, which will be in acres. And then the other thing that people will do is they'll take these perimeters and they'll bring them into GIS, and they'll calculate the acres in a shapefile. So there will be some difference between the because this MTT parameter is a vector representation of a raster output. That's why it looks chunky like it does here. And so the MTT parameters will have, if you calculate them in GIS, will have a slightly different acreage associated with them than they will for the same fire with from the fire size list. So it's quite likely that if you went to fire 0 and looked at the acreage here, and then the shapefile is going to have the same fire number 0, which would directly allow you to link the MTT perimeters to this text file here. The acreage will likely be a little smaller in the vector representation than the raster representation.
Okay. Steve Garza wants to know if you can keep, do we need to keep reinstalling the program as you update the install file?
Yes, we're having to do that for a couple of reasons. We could just provide you a new executable file to overwrite the executable file in the folder where you've installed it, but then every time you click it, at least on government laptops, it's going to say, I don't recognize the registry certificate, are you sure you want to run this? So the way that we've resolved that right now is every time there's an update, you're going to have to uninstall the program first. It will just uninstall the program files, not your files, and then that you've generated with the program, and then install the newest version.
Okay. The next question comes from the Rocky Mountain Research Station conference room. And that actually reminds me, if you're in a situation where there's multiple people viewing the webinar, say in a conference room or any other sort of setup, could you send a quick message here in the questions just to let us know how many are in your group so that we get an accurate count of the attendance? But the group from the conference room asks, what is the effective difference between a non-burnable fuel model class and a barrier?
Well, they both have the same effect, right? If your fire is moving across a landscape and it hits a non-burnable pixel, it's not going to burn. The barrier assumes that maybe you have an area that's a treatment or some other barrier that you don't have accounted for in your landscape yet, or something that you're interested in using, and then it allows you a way to change that to a barrier without altering your landscape. So they both have the same effect. The difference would be is if you don't fill the barrier, then anywhere interior to that barrier could burn based on the fuel models that are contained within it.
Okay. Jeff Shelton asks, can you expand on the assumption of the spotting source? Is it only for the timber models?
For spotting to occur within any of the models like FARSITE or FlamMap, it has to have a crown base height, a canopy cover, a crown bulk density, and a stand height. So typically we associate those with timber layers. Now, if you look at the landfire data, they have some of their fuel models that they've said they'll use a shrub model, and you can assign, and they will have canopy characteristics. In that case, that shrub model or grass model will loft. It will transition from a crown fire, just like a timber model. It'll loft, has the potential to loft embers and cause spot fires, just like in a timber model. So you can have more spotting if associated with a grass or a shrub model if you want to do it, but you have to give it canopy characteristics first. Typically, a grass or a shrub model, say like a 142 or 141, for example, in the Scott and Bergen models, typically they're just that, and they have no canopy characteristics. But if you give them some canopy characteristics, they will loft embers from that fuel model, just like a timber model.
Okay. Brenda Wilmore wants to know if you have to launch a run to see the wind vectors.
Yes, we took that away. In the older model, you could supply the wind information you wanted, and there was a button that said create display, and it would show them right away for you. It would build them right away for you. In the newest version, we've taken that away, but it's a simple thing. You just tell it what you want from a wind vector perspective. Just go to a basic run tab, just pick one output, say run, and the vectors will be there. Due to some other issues, every time you do a new run, it basically destroys your previous wind vectors in that single run, and so now you have to. That's why we're creating WindNinja vectors on every time you do a run.
Okay. Well, the last question comes from Brad Reed, and he wants to know if you're wearing shorts and Birks. And Brad, well, first off, I'll say that we have a very strict dress code here for presenters, but I can't confirm that since we're in different states.
I have shorts and chacos on today.
All right. Well, thanks, Chuck. We appreciate it. And for anyone out there, the recording of this will be up on Advances in Fire Practice in about 45 minutes to an hour, and I'll have the link up there, and you can pass that on to anyone you think might be interested. And this will also be archived on the Lessons Learned Center's YouTube channel, I believe is where we're going to try to put it this time. And this will be up there for anyone to take a look at, any time in the future. All right, Chuck, well, I appreciate your time and effort. Thanks.
All right, thank you, everybody.